Okay, so last time we were graphing lines and we said we realized, hey, all of these equations, they're called linear equations because their graph is a line. And we said, hey, if it's a line, I just need 2 points. Any 2 points determine a line. Like here's a point and here's a point, and there's one line that goes through them. So if they're all straight lines, and saying straight is just being redundant, right? Just kind of reiterating. Because if it's not straight, we don't call it a line. We call that, just a minute, get my pen. We call that a curve, right? But mathematically or otherwise, saying line automatically implies it's straight. Okay, so if they're all straight, the only difference in one line and any other line, other than where they're located, is how much they're sloping, right? So this idea of slope, the slope of a line, becomes very important. Okay, so let's see what it is. If I have this point, which is just some x and y, and this point is some other x and y, but they're both on the line, then if I count, now I know they've done this over here, but I'm going to say if I count how far up I have to go compared to how far over, okay, so I go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6 to get back on the line, up 4 and over 6, that's our slope. Okay, now it doesn't matter which point you start with, as long as I remember that I have to do the up and down first. So if I would have started over here, they went down 1, 2, 3, 4. So down 4 is represented by -4, and then backwards 1, 2, 3, 4, 5, 6. Backwards 6. Notice it's the same thing. Both of these simplify to 2/3. So it does not matter which point you start with, but what does matter is you have to do the rise first. So one thing we say is rise over run. Rise over run. That's our slope, right? You're just comparing, oh, how high up compared to how far over you have to go to get back on the line. Okay, rise over run, or y's over x's, right? Rise over run, y's over x's. That's how we determine the slope of a line. And if I'm looking at a graph, I can just count it, right? And I just made like there is a grid here. I don't know really what the grid is, but you would count up your grid marks. Okay, now that gives us a formula for the slope. And a lowercase m is reserved for slope. Anytime you see a lowercase m, you know you're talking about the slope. It's not an S because the French beat us to naming it, okay? So m stands for slope. And I have this formula right here. The change in y over the change in x is the same thing as rise over run, the y's over the x's. But to calculate the rise, all I do is see how far it is between the two y points, and the run is how far it is between the two x points. Notice when we're talking about how far something is, we subtract. How far is it from 8 to 10? It's 2, because 10 minus 8 is 2. How far is it from 50 to 80? It's 30, because 80 minus 50 is 30. Right? So I've got a formula that I got to memorize for the slope of a line. Okay, so this is saying find the slope of the line that goes through these 2 points. So I got to memorize that formula. M is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is just telling us to be sure and keep the points in the same order. It's not telling you an order that you have to subtract them in. It's just saying pair them up, right? So with this one, if I'm starting with my slope and I start with this point, the y is 1, and then I have to subtract this y, right, in the same order. Now be careful, there's a minus in the formula, so if your number also has a minus, we got to account for both of them. Now, because I started with this point on my y's, I have to start with this point on the x's. This is what this ordering is telling us. So then that would be 3 minus 3. Okay, so this is 1 plus 2 and 3 plus 3, right? Or 3 over 6, which reduces to 1/2. Okay, the slope of the line that goes through those points is 1/2. Let's do this one. Okay, this time maybe I'll start with this point because it doesn't matter. So 4 minus 2, but because I started with this point on my y's, I have to start with this point on my x's. So -1 minus 1. Now I just have to do the math. This is 4 plus 2. And these signs are the same, so I add the numbers, but keep the sign in the biggest one. So this is 6 divided by -2, or -3. Okay? So it's just plugging into a formula to find the slope. Plugging into that formula. I gotta pay attention to that formula. Now, notice they're just saying right here, it makes no difference which point you start with. We just looked at that. It doesn't matter. Okay, you just have to be consistent. Okay, now there's 4 things that can happen if you're talking about a slope. Your line can slope up, your line can slope down, your line can be horizontal and doesn't slope at all, or it can be perfectly vertical. If your line slopes up, that means you have a positive slope. If your line slopes down, that means your slope is negative. These last two are special cases. Remember last time we said if we have an equation that just has one letter, it's special, and nothing, not the other methods make sense. We just have to stop and say, oh, it's special. Same thing here. This slope is 0, and this slope we call undefined. Okay, these go along with our special equations. Remember when we were graphing them, one was a vertical line and one was horizontal. So everything about these special equations I just have to memorize. And once I know one thing about them, I can get all 3. Okay, but I'm not plugging into formulas or doing anything like a typical line. These are special. Anytime I see an equation with one letter, it's special. If I see a graph that's completely flat, horizontal, or vertical, it's special. If I see a slope that's 0 or undefined, it's special. Okay, and then all those three things go together. For example, look at this. Let's imagine that this is on an axis, right? And because this is going through the y-axis, then I know my equation is y equals, let's just call that 1, right? This one is vertical, so it's going through the x-axis, so I automatically know my equation is x, whatever number it's going through. Okay, this slope is 0. It's flat. It's not sloping at all. It's perfectly flat. It's hopefully like the table that you've got your computer sitting on. It's flat. It's horizontal. There is no slope. Okay, this line is so sloping so steep you couldn't even climb it. It's straight up like a wall. So we call that undefined. I can't even tell you how steep that is. Now the reason that is if you get a slope when you're trying to calculate it with a denominator as 0, remember you can't divide by 0. You can't have zeros in denominators. You can't divide by 0. We call that undefined. Okay, so here's another one. Find the slope of each line. So I've got that formula. Okay, so y minus my y value, because I started here with my y's, I got to start here with my x's. So 4 minus 4, which means, oh, this is 0 over 4 plus 4 over 8, 0. Hey, I know my graph is a horizontal line, and I know the equation to this is, look, y equals 2. Y, look, on both of them, yeah, y is 2, y is 2. That's my equation, y is 2. So if I get any one piece of information about these special ones, I know everything about them. Okay, let's try this one. Okay, 4 minus 1, because I started here with my y's, I got to start here with my x's. Negative 3 minus 3. So that's 3 over negative 3 plus 3 is 0. You cannot leave this. Your answer has to be, oh, that's undefined. So once again, I know everything about that graph and that equation and that slope. It's one of my special ones. Right? The equation of this, because it's a vertical line, it cuts through the x-axis. Oh, and look, x equals negative 3. That's the equation if I was looking for the equation, which we're going to be shortly. Okay, so our special ones. Okay, they're just reiterating what we just found out. Horizontal lines have a slope of 0. Vertical lines have an undefined slope. Horizontal lines equations is the y equals your number. And vertical lines equations is x equals the number. Okay, find the slope from the equation of a line. Here's something interesting and really useful. Okay, so if I have 2 points, I've got that formula I memorized, right? My formula for the slope. But if I'm given the equation, and if I'm looking at the graph, I just count. So I can be given 2 points, I can find the slope by plugging into a formula. If I'm looking at the graph, I can find the slope by counting up and over from one point to the other. If I am looking at the equation and I need the slope, I solve this thing for y. Okay, remember we've done this before, solve for a particular variable. I'm going to solve for y. That means I want the y's over here, everything else on the other side. So I'm going to subtract 5x from both sides. That means this is gone. So I'd have negative 6y equals negative 5x plus 2. And then divide by negative 6. Everything all the way across. Okay, so that means, here's my equation. Y equals a negative is a positive. And then this will reduce to a negative 1/3. When I have the equation of a line, if it is solved for y, if the y is all by itself on one side, then the number, the coefficient of the x term is your slope. This is going to be so helpful to us. So if I'm looking at the equation, I solve it for y. Or if it's already solved for y, the number in front of the x, the coefficient of the x, is your slope. So now I can find the slope whether I'm given points, whether I'm looking at a graph, or whether I'm looking at an equation. Okay, while we're talking about slopes, Let's talk about parallel and perpendicular. Parallel means you've got two lines that never, ever, ever cross. The only way that can happen is if they are sloping at exactly the same amount. So two lines with the same slope are parallel. Perpendicular lines means they cross at a 90-degree angle. Okay, that means their product is -1. Another way maybe to think about this for perpendicular lines is that they have negative reciprocal slopes. Perpendicular lines have negative reciprocal slopes. Parallel lines have the same slope. So let's refresh our memory on what it means to be a reciprocal. The reciprocal of 2/3 is 3/2. Reciprocal just means flip it upside down. Remember, when you're dividing fractions, you use the reciprocal. You flip. Okay, so if you have one line with a slope of 2/3, then if another line has -3/2, they're perpendicular. Okay, think about this. If you have a slope of 1/4, then perpendicular, would be -4/1, or just -4. So remember, if you had a slope of, let's say, -2, the reciprocal of -2, because really if I see it as a fraction, would be 1/2. Okay, so that means decide whether each pair of lines is parallel, perpendicular, or neither. To determine if they're parallel or perpendicular or neither, I need to know the slope of each one. If I'm looking at equations to find the slope, I solve for y. Okay, so let's do a first. So I need to solve each one of these for y. So I'm going to subtract x from both sides. That means I have -2y equals -x plus 4. Let's divide by -2 all the way across so that we have y equals, this is positive 1/2, x minus 2. Okay, so the slope of this line right here is 1/2. Let's find out what the slope of this line is. Solve for y. We would subtract 6x. So 3y equals minus 6x plus 9. Divide by 3. So y equals -2x plus 3. The slope of this line is -2. So they're not the same. They're not parallel. Are they negative reciprocals? Is one positive and one negative? Yes. Are they reciprocals? Yes. These lines are perpendicular. That's a little shortcut symbol for perpendicular. Okay, let's try the others. All right, let's solve this for y. So let's subtract 8x. From both sides, we would have -2y equals -8x plus 4. Divide by -2 to give us y equals 4x minus 2. What's the slope of this line? Right, 4. Okay, let's subtract 5x from both sides. So y equals -5x minus 3. It's solved for y. So the slope of this line is -5. Oh, well, those aren't reciprocals and they're not the same. Those lines are neither parallel nor perpendicular. One more. Okay, let's add x to both sides. So y equals x minus 3. The slope of this line is 1, right? If there's not a number there, it's understood to be 1. Let's subtract 5x, solve this one for y. So negative 5y equals negative 5x minus 10. Let's divide by negative 5. Okay, so we have y equals x plus 2. The slope of this line is 1. They're exactly the same. These lines are parallel, and that's the little shortcut symbol for parallel. Okay, so go practice finding slopes. 2 points, you got a formula. A graph, you count from point to point. An equation, you solve it for y. Okay, see you next time.